Hello, Algebra 2 Honors. Today we're going to be looking at section 6.2, which is right triangle trigonometry. This lesson will have a lot of content, a lot of formulas and identities. And so it's going to be broken up into 4 videos. My hope is after you watch one video, you carefully go over that content again and make sure you're comfortable with it before you move on to the next video, okay? So we're going to be looking at a right triangle. And I'm going to define the side lengths to be A, B, and C. If you remember, C is the length of the hypotenuse. The hypotenuse is the longest side of a right triangle, and if you notice, it is the side opposite of the right angle. A and B are what we call the legs of our right triangle. Do you guys remember the Pythagorean theorem? This is a theorem that you've seen before, right? And it tells you the relationship between the sides of a right triangle, right? Anytime you have a right triangle, we know that the sides of the triangle will satisfy this equation. Make sure you don't forget this. This is going to be a very useful theorem today. And the one thing to note is that you only use this when you're dealing with a right triangle, okay? So just keep that in mind. Another word that you remember from geometry, hopefully, is the word acute, right? An acute angle. So what does it mean if theta is an acute angle? Well, one thing you can say is that the angle theta must be between 0 and 90 degrees. This is when we're talking about an angle in degrees, right? But then from our last lesson, we did talk about radians as another way to measure angles. And so if I were to write this in radians, right, it would be between 0 and pi over 2 radians, right? If you remember, pi radians is equivalent to 180 degrees. So pi over 2 radians would just be half of 180, right, or 90 degrees. And this is how we can define an acute angle in radians, okay? So hopefully this is kind of a little review. Let's continue on with this lesson. Next thing I'm going to do is I'm going to draw another right triangle. I'm going to label the sides A, B, and C. And I'm going to define this acute angle here to be theta. A lot of times when we're referring to the side lengths, I'm going to refer to this side length as opposite theta. Hopefully you can see why, right? This is the leg that's opposite of the angle theta. I'm going to call this side here the side that's adjacent to theta. And as usual, C will be my hypotenuse, okay? Make sure you're okay with these words like hypotenuse, opposite, or adjacent, because these are words that we're going to be using a lot throughout this lesson. Let's go right into our 6 trig functions. So in geometry, you probably learned 3 of the trig functions, right? Sine, cosine, and tangent. There's actually 6 in total that we're going to be looking at today. The 6 trig functions of acute angles. One of the trig functions you learned last year was the sine of theta. A lot of times we'll write it as sine theta like this, using just the first 3 letters. And the way we define sine theta is as a ratio, where we take the opposite theta and divide it by the hypotenuse. So in the example above, the opposite of theta would be B, and the hypotenuse would be C. If you remember, we use the acronym SO to remember what sine represented, where S stands for sine, O stands for opposite, H stands for hypotenuse. Then we also learned another trig function, cosine of theta, right? Here we could write this as cosine theta using just the first three letters. And cosine of theta, the way it was defined, was to be the adjacent over the hypotenuse. Looking at our triangle, right, and looking at where theta lies, the adjacent would be A, and the hypotenuse would be C. If you remember, the acronym we used here was CA, where C stands for cosine, A stands for adjacent, and H stands for hypotenuse. Then we learned another function, the tangent function, right? Tangent of theta. And we would write that as just using the first three letters once again, tangent of theta. And we define that to be the opposite over the adjacent. In our case here, the opposite of theta would be B, and the adjacent would be A. And the acronym that we used for tangent was TOA, where T stood for tangent, O opposite, and A adjacent. Hopefully this is all ringing a bell, right? But this is SOHCAHTOA. Now this is only for the first three trig functions. There's actually still three more left. And we're going to be looking at those now. Another trig function would be cosecant of theta, which we can abbreviate as CSC. And so cosecant of theta is defined to be the hypotenuse over the opposite, which would be C over B. And then we have secant of theta, and that's going to be abbreviated using the letters SEC, just the first three letters. And secant of theta would be defined to be the hypotenuse over the adjacent, which in this case would be C over A. And then finally, we have the cotangent of theta, abbreviated as COT, cot. Cotangent of theta would be adjacent over opposite. Again, looking at the triangle at the very top, my adjacent is A and my opposite is B. And so these are going to be your 6 trig functions, right? We have sine theta, we have cosine theta, we have tangent of theta, and then we have cosecant of theta, we have secant of theta, and we have cotangent of theta. And so we're going to be looking at these 6 trig functions, and we're going to be finding the value of the 6 trig functions for a given angle. So let's go right into our first example. So for this example here, what we're going to be doing is we're going to find the value of each of the 6 trig functions of the angle theta. So let me draw a triangle here. Again, this is a right triangle, right? This is why it's called right triangle trigonometry. I'm going to define this angle here to be theta. I'm going to call this side here 12. I'm going to call this side here 13. And what we're going to do is we're going to try to find sine theta, cosine theta, tangent theta, and the other 3 evaluated at theta. The first thing you want to do, though, is you want to find this missing side, right? We're missing this leg. I'm going to call this A. This is B. And this is going to be C. So here we're going to use the Pythagorean theorem, right? A squared plus B squared equals C squared. Here will be A squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. Here we're going to subtract both sides by 144. And then when I square root both sides, I'll get A equals to 5. Now, before I go into the 6 trig functions, what I like to do is I like to define the sides and label them as opposite, adjacent, or hypotenuse. So because theta is right here, I know that this side here would be my opposite, right? So I'm just going to put opposite here. The longest side of a right triangle will always be my hypotenuse. And then this side right here, because it's right next to the angle theta, that must be my adjacent. Then I'm just going to quickly write SOHCAHTOA just to remind myself what the first three trig functions will be and how to find them. And so now we're going to go and first find sine of theta. So sine of theta would be opposite over hypotenuse, right? That would be 12 over 13. Cosine of theta would be defined as the adjacent over the hypotenuse, which would just be 5 over 13. And then tangent of theta would be opposite over adjacent, and that would be 12 over 5. And these are the first three trig functions. But there's three more. We have cosecant of theta, and that's defined to be the hypotenuse over the opposite. And that's going to equal 13 over 12. Then we have secant of theta, which is defined to be the hypotenuse over the adjacent, which is 13 over 5. And then lastly, we have cotangent of theta, which we define as adjacent over opposite, which is just 5 over 12. Now, hopefully you noticed something, right? When we found these three trig functions on the right, hopefully you were able to notice that, hey, sine of theta, which was 12 over 13, if you look at what cosecant of theta is, it's just the reciprocal, right? Similarly, when you look at cosine of theta, that was equal to 5 over 13. When you look at secant of theta, that's just 13 over 5. We're just switching the numerator and denominator. And lastly, when you see tangent of theta, and that's 12 over 5, cotangent of theta is 5 over 12. So there's this relationship here, right? Where, hey, if I know what sine theta is, I can just take the reciprocal, and that's going to give me cosecant of theta. In other words, what would have to be true is that cosecant of theta is really just 1 over sine theta, right? Similarly, I could have found secant of theta by just taking the reciprocal of cosine, right? This is just 1 over cosine theta. And I could have also found cotangent of theta by just taking tangent of theta and taking its reciprocal. So this is a lot nicer because if you know sine, cosine, and tangent, you just have to figure out which trig function that's going to go with, right? Cotangent goes with tangent. That's kind of easy to remember because they both have tangent in it. But these are the two that people tend to make the most mistakes, I think. The way I remember what goes with what is I just look at the first letters and make sure they're always different. So what I mean by that is the cosecant, for example, starts with the letter C. I know that cosecant will never be the reciprocal of cosine because they both start with the letter C. I know it's going to be the reciprocal of sine because they have different starting letters, right? Similarly, I know that secant of theta is really 1 over cosine because, again, they have the first letters are different. Secant of theta will never be 1 over sine theta, right? This is a trick that I use to remember what cosecant goes with and what secant goes with. Again, cotangent goes with tangent because they both have the word tangent in their name, so that's kind of easy to remember. But this is a trick for cosecant and secant, okay? So at this point, I'm going to put a problem up, number 2. And just like before, I'm going to draw a right triangle. This time I'm going to call this angle here theta. I'm going to define my sides here to be 4 and 5. At this point, I want you to try this on your own. I want you to press pause, and when you're done, press play, and let's see how you did. So the first thing we're going to do is we're going to find this missing side. I'm going to call this A. This is going to be B. And make sure C is always your hypotenuse. So using the Pythagorean theorem, right? A squared plus B squared equals C squared. 4 squared is 16, 5 squared is 25. Subtract both sides by 16, and when we square root, we get 3. So I know this is 3. At this point, I'm going to label my sides. I know that this is going to be my opposite. I know that this is going to be my adjacent. And I know that this is going to be my hypotenuse. Now at this point, I'm going to find all 6 trig functions at theta. So let's go right into sine of theta. Again, if it helps, write these out somewhere, right? So you can just use it as reference. So SOHCAHTOA. So I know that sine of theta is opposite over hypotenuse. And that's going to equal 4/5. I know that cosine of theta is adjacent over hypotenuse, and that's going to be 3/5. I know that tangent of theta is opposite over adjacent, and that's just going to equal 4/3. Now let's find the other ones. Now I'm going to do cosecant because I know that cosecant is just a reciprocal of sine. So if sine is 4/5, I know that cosecant will be 5/4, right? It'll be hypotenuse over opposite. Next, I'm going to find secant of theta. I know that's the reciprocal of cosine, so I know it's hypotenuse over adjacent, or just 5/3. And lastly, I know what to do for cotangent of theta because that's the reciprocal of tangent, and that gives me 3/4. Hopefully you're able to do well on this example. Make sure you understand how to use SOHCAHTOA. Make sure you memorize these trig functions and what the ratios are.